Hello and welcome to this video. I always wanted to try the digital mode, especially FT8. It seems to be a very popular digital mode among all the hams, and so I wanted to try it. I started collecting some information about this mode, and I soon came to know that there is a software called WSJT-X, which many of you might be already knowing, which is used for FT8 and many other digital modes. I also came to know that there is an interface that is required between the radio and the PC or the laptop, which contains the WSJT-X software. Now this interface performs two functions. The first one is to adjust the audio signal levels between the two devices. For example, signals coming from the radio can be adjusted such that they are suitable for the PC or the laptop, and eventually the software that is decoding the signals. Also, the signals going from the laptop and the software can be adjusted such that they are suitable for the radio to be transmitted further. The second function of this interface is isolation between the two devices. So the ground of radio and the ground of the PC circuit are isolated from one another so that these two devices won't affect each other adversely. I came across this blog post by a guy named Kevin. He designed this circuit called as a Duino radio interface. His call sign is KB9RLW. You can search Duino and you will get his blog post, and also he made a YouTube video about the same. This is the schematic that he had designed. He introduced Arduino Nano into the circuit for the functionality of Vox. So I thought, okay, this seems to be good. Let's try it out. And I built this one on a general purpose board and tried it out. It worked really well. The concept is really simple. He used a USB audio dongle. Now this audio dongle has got the mic input and headphone right output and headphone left output, and this audio dongle gets connected to the laptop by USB. Now if you see, the speaker out of the radio, it is called as the radio audio out, is given to the mic input of the USB dongle. It is given through a capacitor C1, which is of 10 microfarad, as can be seen here. Now this capacitor will block all the DC component. It will block all the noise, and a pure audio signal will pass on to the mic input. Now the output from the USB dongle are headphone right out and headphone left out, out of which the headphone left out is given through a resistor, and it passes through a capacitor C2, which is again 10 microfarad, to the radio audio in, which means that it is given to the mic input of the radio. The signals from the headphone left out can be controlled using this variable resistor or a potentiometer, which is of a 10K value. Similarly, the headphone right out, which is again the same signal, is passed through this capacitor C3, which is of 2.2 microfarad. It passes through this amplification stage, then it is rectified and then filtered. This resistor is used uh, to discharge the capacitor when there is no signal present. So a certain level of a signal is available at the analog 1 input of Arduino Nano. Now there are two other potentiometers, R7 and R8. R7 is the delay potentiometer and R8 is the sensitivity potentiometer. So whenever the signal is present at A1, it is compared with the value of the sensitivity potentiometer, and this particular value decides when to trigger the PTT. The PTT is triggered through the digital output pin D13. Similarly, whenever the signal is gone, the delay potentiometer decides when to drop the PTT. So this is the function of R7 and R8, which is delay and sensitivity. The PTT circuit is seen here. So the digital output D13, when it gets activated, the PTT from the radio gets grounded, and that's how the PTT of the radio is triggered. Kevin explains this circuit very well, and you should definitely check out his blog and as well as the YouTube link, which I will post in the description below. But this is the basic concept of the circuit. This circuit worked really well when I tried it. However, this circuit has a couple of things missing. Like I said in the beginning, the function of the interface is to control audio signals from radio to the software and from software to the radio. So there was this TX drive, which he calls, is present here in the circuit. However, there is nothing to control the signals coming from the radio into the mic of the dongle. The second and most important part of this circuit, which was missing, was the isolation. So this radio interface did not provide isolation between the radio and the PC. Of course, Kevin mentions in his video and in his blog that you can introduce isolation transformers here so as to separate out the two parts, the two devices. So I decided to introduce similar to TX drive, a RX drive, which will control the signals coming out of the radio and entering into the mic input of the USB dongle. And secondly, I decided to introduce isolation transformers at this stage so that the proper isolation between the two devices can be achieved. So the circuit that I designed is heavily based on this radio interface designed by Kevin, with the changes that I mentioned. So in Easy EDA, I designed this circuit, and here you can see that along with TX drive, there is RX drive as well, and there are isolation transformers. So now I addressed the two issues that were missing from his circuit. One by introducing a 10K port here, which is called as the RX drive, and by introducing isolation transformers here. The rest of the circuit is pretty much the same. There is one more place where I made some changes. Here, if you see, there was no isolation between the radio PTT and this circuit, which is again interfaced with the laptop. So there has to be an isolation here as well. And so I introduce an opto isolator called MCT2E. So now the PTT, which is the radio side, and the other side of the circuit, which is the PC side, are isolated with this MCT2E. So this is one of the other changes that I made in the circuit. I printed this circuit out on a PCB, and it performed really well. Here is the PCB that I made, and you can see the Arduino Nano here. This is the MCT2E, which is an opto isolator, optocoupler. These are the two isolation transformers, and this is the USB sound card or USB dongle. It is actually it called a USB sound card, the external one, so which has got a mic and audio out or a headphones jack, and I have typed connections from the mic, the headphone left and headphone right out. These are the 10K ports. There are 4 of them. One is the TX drive, the other is RX drive, one for delay and one for sensitivity. And this is the switch, which can be seen here as well in the original circuit, which just powers the amplification stage and the Arduino Nano, and also the delay and the sensitivity ports. So if you switch off this switch, there won't be power to the amplification stage and the Arduino Nano and the delay and the sensitivity potentiometers, and so which means that there won't be any triggering of PTT through this circuit. However, the audio channels will still work. So if you switch off this switch, the PTT circuit won't work. So this can be useful if you want to control the radio using cat communication. So you will require another USB cable running between the laptop and the radio, and the PTT can be triggered over cat. So if you want to use it that way, then you can switch off this switch, and then the WSJT-X will control the PTT of the radio over cat. But if you don't want that, if you want a hardware controlled triggering of the PTT, you can switch this on. The advantage is that then you will be able to use the delay and the sensitivity feature of this circuit. So you have an option here. You can use it any way that you want. So that's the switch that's shown here. Here is the interface that I've made. Here you can see the 4 potentiometers. The first one is the TX drive, which controls the signals from WSJT-X going towards the radio. The second one is the RX drive. So the audio signals coming from the radio into the WSJT-X softwares can be controlled using this potentiometer. The next two are the sensitivity and the delay, which we talked about earlier. In fact, Kevin demonstrates the sensitivity and the delay um functionality of this interface very well in his YouTube video. Please do check it out. So on this side, you can see there is a aviation plug, and this cable is connected to the front jack of the radio. Now there are four pins available here. There is PTT, there is ground, there is mic and speaker. So audio signals from the radio are available at the speaker pin, which goes into the mic input of the external USB sound card, and the signals that are to be transmitted go from WSJT-X out of one of the headphone out into the mic in of the radio, and of course the PTT goes to the PTT and it is triggered uh, via this circuit. This is the switch we talked about earlier. So if I switch it on, the hardware will be used to trigger the PTT. If it is switched off, then you can connect another USB cable to the radio, and the WSJT-X will trigger the PTT over CAT. I usually keep it on because I let the hardware trigger the PTT. That way I can use the sensitivity and the delay feature of this interface. This side, there is the USB cable connected to the sound card inside, which connects to the laptop. So I have opened up the WSJT-X software. The first thing that we need to do is go to settings and audio, and make sure that the input and output both are USB audio device. Since we have connected our interface to the laptop, we need to choose the input as USB audio device and the output as USB audio device as well. The first functionality that we'll check is the RX drive. So on the left hand bottom side here, you see the signals that are being received from radio by this software. It is recommended that this signal remains green in color. The level should be adjusted that it is green in color. If it is red, then it's not good. And so for that purpose, you can use the RX drive to control the level of the signal. Here you can see that I'm decreasing the level by rotating the knob anti-clockwise, and I can increase the level too by rotating the knob clockwise. I will adjust such that it is in green color. So that's the functionality of the RX drive. Okay, now I've adjusted my camera to face the power meter. What we will do is now check the functionality of the TX drive. If I press enable TX, the WSJT-X will trigger the PTT of the radio, and you can see the forward voltage on the power meter. And by using the TX drive knob, you can adjust this output power. So here we go. I would press enable TX, and after it finishes its receiving cycle, it will go into the transmit mode, and you will see the forward power. Okay, it has gone into the transmit mode, and now I'm reducing the power using the knob, and now I'm increasing the power using the knob. This way you can adjust the TX drive. Let us now check the sensitivity functionality of the interface. Right now the sensitivity knob is turned completely anti-clockwise, so it is least sensitive right now. I will put the WSJT-X into enable transmit mode, and now you will see that it is trying to transmit, but there is no forward power. The PTT is not being triggered. This is because the circuit is at least sensitive setting. Now what I will do is I will increase the sensitivity by turning the knob clockwise, and then you will see the PTT being triggered. Okay, now WSJT-X has gone into the TX mode, but there is no forward power. Now I'm going to just rotate it, and there it goes. This is the level where it got triggered. So this is the sensitivity functionality of the interface. Similarly, the delay knob, whenever it is turned anti-clockwise, it's 0 second, and whenever it is completely turned clockwise, it is 2 seconds delay. So anywhere in between are the values between 0 and 2 seconds. So this decides when the PTT should be dropped after the signal is gone. So here, whenever the signal drops at A1, the delay knob decides after how many seconds to drop the PTT. All these functionalities are really well explained by Kevin in his videos, and I suggest you watch that video. It will give you a better understanding of the circuit. So this is about the interface that I've made. It is working really well with the added functionalities and added protection of isolation. This becomes a very complete circuit, and it won't cost as much as the commercially available interfaces. You should try this circuit sometime, and it will serve you really well in exploring the digital modes. Thank you very much for watching. If you have liked this attempt of mine, give it a thumbs up and consider subscribing to my channel so that you will come to know whenever I put videos like this, and also press the notification bell. Thank you very much for watching the video.